So let's talk about binary. The first thing you need to know is that all numbers have bases. So if I write down a math expression here, let's say 10 plus 11, we know that this is in base 10 implicitly because we've done this since we were kids. For most people, expressing numbers in base 10 is all they're ever going to have to do. But once we start getting into computer science, because of the way the low-level systems in our computers work, we need to start expressing numbers in different ways. And one of the ways to do that is binary. We also start expressing numbers in base 16 and base 64 just for convenience. But today we'll just go over base 2, which is binary. So what base 10 really means is that every digit in a number that we're expressing is a specific power of 10. And actually what ends up happening is we only have 10 digits to express each digit in a number. So 10 symbols, 0 to 9, can be used per digit in a base 10 number. Let's take 657 for example. This number, every single digit, represents a power of 10. We know this implicitly, but let's break it down. We know that the least significant digit, the 7, represents the ones. We know the next one up represents the tens, and the next one after that represents the hundreds, and so on. So if we break this down a little more, we can actually make all of these numbers a specific power of 10, 10 being our base. And so the 7 is the amount of 10 to the power of zeros. The 5 is the amount of 10 to the power of ones, which equals 10. The 6 is the amount of 10 to the power of twos, which equals 100, and so on. So how do we generate the number from this? Well, it's actually quite easy. We simply look at the digit and then look at what that digit represents and count that many of that representation. That may have sounded confusing, but here it's literally 7 ones, 5 tens, 6 100s. This is how numbers work. And if we take the sum of these, we end up with 657. Binary is base 2, and we can use the exact same concepts to translate this number over here, 1 1 0 1 0. Since binary is base 2, there's only 2 symbols that we can use to represent each digit, 0 and 1. And each digit in the number is going to be a specific power of 2. So if we run through this number, doing the same thing going backwards, 2 to the power of the next digit, we end up with 2 to the power of 0, 2 to the power of 1, all the way to 2 to the power of 4. Now, if we work out what those powers represent, we know that we have the number of 1s, the number of 2s, the number of 4s, the number of 8s, and the number of 16s represented by each digit. So now all we need to do is count the number of 1s, 2s, 4s, 8s, and 16s based on the digit in the number. So we have 0 1s, 1 2, 0 4s, 1 8, and 1 16. Now if we put this all together, we add them all up, we realize that this binary number actually just represents 26. And that's it, that's binary. Now if you feel like you understand this concept, you can stop the video now. If you just want to do one more example, I'm going to do an example of working out a number in base 7. Okay, so we have the number 161, but in base 7. What does this number mean? We're just going to do exactly the same thing we did before. The first digit is 7 to the 0, next 7 to the 1, next 7 to the 2. And if we work out what the corresponding meaning of these powers are, we have 1, 7, and 49. So let's just do the math. Let's work it out the same way we did before. We have 1 1, we have 6 7s, and we have 149. Add it all together, we end up with 92. So 92 in base 7 is represented by 161. That's all for now, guys. If you want to see more student-made content or more tutorials, make sure to check out the TVM YouTube channel. I'll see you next time.